Have you ever wondered why the universe is flat and not, say, spherical or curved? Today, we're delving into the fascinating concept of the universe's flatness. It's an idea that might seem a bit abstract, but stay with me. You see, our universe isn't merely flat by accident. It's a necessary condition for our existence and the way we understand the cosmos. Picture this: parallel lines that never converge, 90-degree turns that are true to their name, the interior angles of triangles summing up to 180 degrees. All these principles of Euclidean geometry that we learned in school apply to our universe. This is no trivial matter. The flatness of the universe is crucial for science to be applicable. Without this flatness, our understanding of the universe would be drastically different, if not impossible. So let us ponder on this. This flatness is not just a random phenomenon, but a key aspect that allows science to even be possible. So what does it mean for our universe to be flat? Dive with me into this fascinating concept. When we talk about a flat universe, we don't mean flat in the way you'd think of a pancake or a piece of paper. No, we're talking about the fabric of the universe itself. Its very geometry. Imagine drawing a triangle in the vast expanse of space. In a flat universe, the interior angles of that triangle will add up to 180 degrees, just like the triangles we doodled in high school geometry class. If you were to draw two parallel lines extending into the cosmos, they would remain parallel forever, never converging or diverging. This means that our universe adheres to the principles of Euclidean geometry. You know, those rules we learned in high school about shapes, lines, and angles. They hold true on a cosmic scale. 90-degree turns behave as true 90-degree turns. Everything behaves just as our mathematical models predict they should. But why does this matter? Well, the flatness of the universe is indispensable for its stability. It's this precise and consistent flatness that allows us to apply abstract mathematics to the universe. It's the reason why we can make predictions about the movement of planets or the behavior of light years away from us. It's the reason why we can build bridges, design aircraft, or even just throw a ball and know where it will land. In a universe where the rules of geometry did not hold, where parallel lines might diverge or converge, where triangles might not behave as triangles should, science as we know it would cease to exist. Our predictions and calculations would be thrown into chaos. Engineering, a field entirely reliant on the predictability of mathematical principles, would become a game of chance. In essence, without the universe's exceptional, stable flatness, science and engineering would be all but impossible. It's like having the ultimate level playing field, where the rules of the game are consistent, reliable, and above all, comprehensible. And that, my friends, is far from boring. It's nothing short of a miracle. But the universe's flatness is not the only thing that's exceptionally fine-tuned. This remarkable fine-tuning extends to several aspects of our universe, each playing a crucial role in making life possible. Let's take gravity, for instance. This fundamental force that keeps our feet on the ground is dialed in just right. If it were even slightly stronger, stars would burn out too quickly, leaving no time for complex life to evolve. On the other hand, if gravity were a tad weaker, stars wouldn't form at all. The universe would be a vast, cold void. Similar precision applies to electromagnetism. The force that binds electrons to the nucleus is precisely balanced. If it were any stronger or weaker, the chemistry that underpins life would simply not work. Now, consider the strong nuclear force, the glue that holds atomic nuclei together. It's about 100 times stronger than electromagnetism. Yet, if it were only a few percentage points stronger, hydrogen would fuse into heavier elements too readily, disrupting the delicate balance needed for stars to form and for life to exist. Then there's the weak nuclear force, whose primary job is to facilitate certain types of radioactive decay. If the weak nuclear force were different, the universe might be devoid of key elements like hydrogen and helium, spelling an end to the possibility of life as we know it. Lastly, let's talk about the cosmological constant. It's the energy density of empty space, and it's absurdly small. So small, in fact, that physicists describe it as the worst prediction in the history of physics. But if the cosmological constant were not this incredibly tiny value, the universe would either have collapsed back onto itself or expanded too rapidly for galaxies and stars to form. In conclusion, the universe's flatness is but one of many incredibly fine-tuned aspects that allow life to exist. Each of these elements, from gravity to the cosmological constant, is delicately balanced on a razor's edge. Any deviation from their precise values could result in a universe hostile to life. The universe's fine-tuning is what makes the existence of life as we know it possible. Understanding the flatness of our universe has profound implications. It's not just a fascinating fact for stargazers and scientists, but it also lays the groundwork for much of our understanding of the universe and our place within it. You see, this remarkable degree of flatness, coupled with the stability of other constants, is the very backbone of the three-dimensional geometry that we apply to our world and the universe at large. This might seem like an abstract concept, but it has real, tangible implications for our everyday lives. Imagine for a moment a universe where parallel lines didn't stay parallel, where the interior angles of triangles didn't add up to 180 degrees, where the rules of geometry as we know them didn't apply. It would be a universe that our minds couldn't comprehend, a world where our current understanding of physics, engineering, and even the simplest tasks could be impossible. But we don't live in that universe. We live in a universe that, as best as we can measure, is perfectly, totally, ever so boringly flat. This flatness, this stability, allows us to apply the rules of Euclidean geometry to our world. It is the reason why our buildings stand, why our planes fly, and why we can even begin to understand the vast cosmos that surrounds us. This isn't just about the stability of our universe, though. It's about the stability of our understanding. As Einstein said, the comprehensibility of our world is a miracle that is constantly reinforced as our knowledge expands. The universe's flatness is a key part of this miracle. It is the cornerstone that allows us to string 1,000 arguments together without contradiction, to discover the laws of nature, and to grasp the world in a way that makes sense. The universe's flatness, thus, is not just an astronomical phenomenon, but the very foundation that allows us to understand and explore the universe scientifically. And, remarkably, the Bible predicted this essential flatness for the universe thousands of years before it was discovered.